Hey ladies and gentlemen, this is your well-rounded math teacher, Mr. Prakar, and today we're going to be solving using logarithms, a little bit of what we did before, and then I'm going to show you another way that you could maybe use if you wanted to. This is section 8.3, but anyway, just kind of learning what we are working with what we did in the past. First of all, you got to remember that 3 is your base, and x is your exponent in this case. And we're going to use logs to solve this, so we're going to write it as a logarithmic equation. So it starts out with this. When you write it as a logarithm, it's always equal to your exponent. So first of all, you start out with log base 3, write it in that subscript, of 11 equals your exponent x. And then, you can use your calculator and pull up your logarithm. There we go. So I'll pull this up. Get rid of my old work here. So we're going to go in here and go into function again and hit that log base A button right there. We're going to use the common log button in a little bit here, but we're going to use log base A right here. Type in that base 3 and then of 11, and there's your answer. So it's x equals 2.182, and if we round it, that would be 7. So there it is, using the log base button again. But now, kind of want to show you a little bit different way. And you can use your calculator, your graphing calculator, your TI-30 calculator to do it this way. We're going to take the log of both sides. And we're going to use the LOG button, and I'll show it to you here because I want you to see it. It's just LOG, and this is the common log. You don't type in a base because it has a base. And the common log, I'll write it here, log is log base 10. So if you're looking at, if you just see LOG like this, it has a little base 10 there. Okay. So anything with the common log, it's base 10, and it could be any base really, but this is how it works. This is how you would use it. First of all, you're going to take, like if you divide both sides by something or add something to both sides, we're going to take the common log of 3x, or I'm sorry, 3 to the x power. But if I take the common log of this side, I have to take the common log of 11 like this. Now what happens here is the x comes down. That exponent is just, it's going to be x times the common log of 3 equals the common log of 11. And to solve for x, being it's multiplied, we're going to divide both sides by the common log of 3. These would cancel out, and x equals. So I'm going to say the common log of 11, finish off those parentheses, and then divide by, we're going to go in that function button and just get the common log again of 3. 3 is the base, so it goes on the bottom basically, and then x equals 2.1827 again. It's the same thing. So basically, if you have a problem like this, you take the base, which is 3, and you just say x equals the common log of 11 on top and the common log of the base 3 on the bottom, and that's your problem. So it's just another way that you can solve them, rather than using the common log base button. But I'll use that here now so we can kind of get back to normal, but that is another option. So the key is my base right here is 6. So before we can write it with log base 6, you got to get it by itself. So I got to get rid of the 5, so I'm going to subtract 5 from both sides. 4 times 6 to the 2x minus 1 equals, subtracting 5 from that would give me 68. Now, what a lot of people want to do is multiply the 4 and the 6, but the 4 right here is not a base, and it's not to the 2x minus 1 power, so I can't multiply it by the 6. So you have to divide both sides by the 4 and get 6 to the 2x minus 1 equals whatever 68 divided by 4 is. Well, 68 divided by 4, which is 17. Now we can go ahead and write this as a logarithm because I have that base, that 6 by itself. So this is log base 6 of 17 equals your exponent. Always equals your exponent. My exponent is 2x minus 1 right here. So I'm going to move this over a little bit so we got a little bit of room. First of all, I got to figure out what log. So I'm going to go to the common or log base button, not the common log. So log base A here. Actually, let me try that again. Log base A. So this is kind of like we did before. I'm going to hit 6 for my base and type in 17. So now I get this. 1.5812 equals 2x minus 1. So now we're going to go in here and we're going to add 1 to both sides. Now we just solve it like a regular equation. So this is 2.5812 equals 2x. So now we just divide that. 2.5812 divided by 2. So x equals 1.2906. So this is kind of what we did yesterday. Okay. So I guess I would do the same thing here. We could use the common log of both sides, so I'll show you the common log, but you could do the same thing we just did here if you wanted to. I'm just going to show you how to do using the common log, where you divide one log by another log. So first of all, my base is 5, so you want to get that base by itself first again. So I'm going to add 7 to both sides here and get 2 times 5 to the x plus 4 equals 26. Now remember, I can't multiply the 2 and the 5 because 2 is not my base, so I just got to get rid of it. So we're going to divide by 2. And I get 5 to the x plus 4 equals 13. So what I can do is this. It's kind of a shortcut. If you're going to use the common log, my base is 5. So I'm just going to take, and we'll say common log here. And we're going to take the common log here. But what's left over is that x plus 4 equals the common log of 13 divided by, well, your base is 5, so that's going to go on the bottom, the common log of 5. Kind of a little shortcut here. Make sure you put these in parentheses. So let's try that common log. Now you could do log base button again. I'm just kind of showing you a different way to do it if you wanted to on your calculator. So log 13, finish that parenthesis, divided by log, common log of 5, because my base was 5. So I get x plus 4, I'll write it right here, equals 1.59, what is it, 36? And then we just subtract 4 from both sides. And x equals, I'll use my calculator here, 1.5936 minus 4. And we get negative 2 point, you could just say negative 2.4. I'll say negative 2.4064 though. And there we go. So that's just another way to do it if you want to use that common log button instead of the log base button. So now it says solve using any method. I think we'll just use the log base button for the most part. I'll show you another method for B here. But anyway, first of all, I can't multiply the 3 times the 16. Remember, 3 is not to the x power. So before I can do anything here, you got to get the base which is 16 by itself, 16 to the x power. So I'm going to divide both sides by 3. 3's cancel out, and I get 16 to the x equals, okay, 3,000. Let's try that. 3,072 divided by, what is it, 3? 1,024. So my base is 16, my exponent is x, so it's going to equal x. So I'm going to say it log base 16 of 1,024 equals x. And then I'm just going to use the log base button. I think that would be probably the easiest here. So 16, and I'll throw that in there, 1,024. So x equals 2.5. We'll do C here also. Kind of the same thing. Recognize your base. Your base is 4. You got to get that base by itself. So you got to get rid of everything outside of that except the exponent. So I'm going to subtract 7 from both sides, -2 times 4 times 2 to the 3x power equals -26. I can't multiply -2 and 4. I got to divide by -2. So it's 4 to the 3x equals, in this case, positive 13. So now we can kick in that log base button. Log base, my base is 4 of 13 equals, it's always equal to the exponent, is right there, and we're going to put that right here. So cancel it out, use that log base button, 4, and then hit 13. And we get 1.8502 equals 3x. And then just solve for x, divide by 3. So 1.8502 divided by 3. So x equals 0.6167. Okay, I'm going to solve B last. I'm going to go to D right now. Now I got a decimal in there, 1.08, but that's my base. So let's get that by itself. I can't multiply 500 times 1.08. I got to divide by 500 because it's not to the x power. So these cancel out, and I get 1.08 to the x equals, in this case, 4. So now I got my base, I got my exponent, so it's going to be log base 1.08 to the 4. Log base 1.08 of 4 equals the x. So we just use our log base button. That's pretty easy. Just type in that decimal 1.08 and type in 4, and you got your answer. X equals 18.0129. There we go. I want to save this one for last. We could do this one the same way, but I want to show you something. This is kind of what we learned with logarithms in the beginning, or working with exponential functions, sorry. My base is 3, so we got to get rid of that 10, and I get 3 to the 2x plus 5 equals 81. Okay, now we could do this one the same way we did all the other 3. You could. I just want to show you that 81, I know this is 9 times 9, and 9 is 3 times 3, and they're both prime. And this 9 is 3 times 3, and they're both prime. So forgetting the 9s, 81 is 3 times 3 times 3 times 3, or 3 times 2x plus 5 equals 3 to the 4th power. So this one's kind of easy in the fact that I can get the same base. If I can't get the same base, well, then I got to use that log base button. But being these are both 3's, what has to be true here is this. 2x, the exponents have to be equal if it's an equal equation. 2x plus 5 equals 4. So now I can just solve this equation. This is what we did with exponential equations in the beginning. So 2x, 4 minus 5 is -1, and then just divide by 2. And your final answer is x equals -0.5, or you could still leave it as -1/2. And the reason I wanted to show you this is I'm going to help you get going with this. These first two equations, we have to do the same thing. We have to get the same base and then set the exponents equal, because we have variables on both sides, so I can't really do the log base button. But these ones, 3 through 8 and 9, 9's kind of set up for us. You can use that log base button, or you can use the common log button if you want. But 16 here. Well, I could both get these down to a base of 2, but I do know this. 16 is actually 4 times 4. Now I know they're not prime, but 16 is 4 squared. So I could say this is 4 squared equals 4 to the 4x plus 6 power. They have the same base, so the exponents have to be equal. So that means 2 has to equal 4x plus 6. And then you guys can kind of solve that from there. Subtract 6, divide by 4. Let me help you set up this one, because this one's a little bit harder. Actually, it's a lot harder. But I want to go over it with you. Okay? 27. 27 is 3 times 9. 3 is prime. And 9 is 3 times 3. So this is 1 over 3 cubed to the x power. Okay, so the deal with this one is I can't have that power or that base in the denominator, so I got to flip it up. You guys probably don't remember this, but if I flip it up to the numerator, it would become a negative exponent. Okay, and then power to power, we multiply here. This becomes 3 to the negative 3x. You have to do the same thing with 243. It's not in the denominator now. You just have to break it down. 243 is 3 times 81. I'll kind of get you started. That's prime. And then you kind of keep going from there until you get 3 to whatever power it is, and then kind of work it where you multiply that 3 to whatever power it is times the x minus 4, and then you can set the exponents equal. So I'll let you guys do that one. If you get it, great. If not, that's fine. Just to kind of get you going, I think I'll do number 5 here. Now, I only have one variable in the exponent. That's x minus 9. My base is 4. Okay, we just have to get that by ourselves. So I don't have to add or subtract anything. I have to divide by 3. This is for the x minus 9 power equals whatever 192 is, divided by 3, 64. Now I could get these two the same base, but I'm not going to. I'm just going to do log base. My basis for my exponent is x minus 9, so this is log base 4 of 64 equals x minus 9. So let's use that log base button. 4 and then 64. Look at that, it's 3. Equals x minus 9, so I add 9 to both sides and I get x equals 12, and we're good to go. So I'll let you guys finish this up, and that's 8-3. See you, bye.